So we are moving now in a bit more into the hybrid structures. And to present our next project is Bettina Baggenstos. She's an architect and a timber expert. She will present the office building Hortus, which is designed by Herzog de Meuron, combining timber and compressed earth. This is a climate-positive workplace using hybrid floors, solar power, and geothermal energy, built to last for generations. So we'll see, 850 years. Bettina?
Thanks for the introduction. I believe nobody of us will see whether it will last 850 years, so I hope nobody will witness the demolition of this building. To start, this is the most ecological building. It's not a wrong slide, it's on purpose, like it would never be built. Because in terms of ecology, we shouldn't be building anymore. However, right now everybody has been talking about newly built buildings because this is still what we do a lot. Except for the one renovation project of a building that has persisted for several hundreds of years. But we can't only think about the ecological part, we've already heard this, so I won't go deep into it. We have the economical, the society, as well as the ecological part. Hortus, the building that I'm going to present, tries to state a possibility how we can build so that the three aspects of sustainable design will be met. And this is what I'm going to go deeper into today. Quickly about me, exactly, I'm an architect. I work at Blumer Lehmann as well as Lehm. Blumer Lehmann is a timber construction company from Switzerland. Lehm is a daughter company from Blumer Lehmann, Lehm, Erde, and GBD, which I will quickly present as well, and I'm kind of working for both companies. I will quickly introduce Lehm so that the whole constellation makes sense for you. Then I'm going to go into why should we even combine earth and timber. I'm going to talk about how we put this theory into practice in the project Hortus. And how we plan on continuing the innovation in the hybrid structures of timber and earth with Lehm. So as I said, Lehm has been founded between three companies. The three of them have very special knowledge. So Blumer Lehmann has been building in timber for 150 years. We've just celebrated our 150th anniversary this year. Lehm Erde has been building in rammed earth for the last around 30 years. And they're pioneers in the rammed earth construction. And GBD is an engineering company that do testing of forces. They also burn down buildings, and they work on getting new codes and regulations. This is the factory of Lehm Erde, where they have produced the first machine to prefabricate rammed earth walls in an off-site factory, basically, that they then deliver to site and assemble there. And this is our new office building that we've opened this year. And it shows that we basically do anything out of timber. So we don't only do straight beams or modules or anything. It's like, as long as it's out of timber, we're willing to go for it and try to make it possible. So the three of us have decided that we need to go further and not just stay in our fields, but we need to join forces to drive innovation in building systems with earth and timber. But yeah, why should we build in earth and timber? This morning we've seen the city Shibam in Yemen, which is built in earth and timber, and it's persisted for several hundred years. That can be a reason why we should build in earth and timber. I was already wondering about that before I even heard of Project Hortus. I wrote my master thesis 6 years ago on the topic of earth and timber construction, and I looked at vernacular architecture as well as contemporary examples of different earth and timber construction. I defined them into typologies. I tried to kind of look at timber construction with a little bit of earth, and on the other end of the scale is earth construction with a little bit of timber. and everything in between. In vernacular architecture, there's many different typologies, how they have been put together, how they used the local materials. And it was interesting to see what are the possibilities nowadays with the means of production and construction that we have. This is one example of a Hakatulu in China. On the left-hand side, the massive wall, which is kind of one of the typologies that I identified, that you have like a massive core and then, or like a massive wall, and then inside you have a light core out of timber. So on the right-hand side is a building in France, a museum, that has kind of been built in the same logic. There's many other examples. I mainly did the thesis so I could look at many timber and earth buildings, to be honest. While looking at the buildings in timber and earth, I learned a lot, and I'm going to share some of the insights with you before I go into Hortus. So the material sourcing, like in vernacular building practice, the material sourcing was very different than what we do today. Today we can just buy everything off the shelf and we can deliver it around the world and get it from everywhere. Before, or like in vernacular architecture, they had to use what was there. They had to use what was easily accessible and then make a building out of it. Now we can think of how they did it because they didn't have as much energy, they didn't have as much power, and they still found solutions to build houses where you can live in. So maybe we should just get inspired by our ancestors. We've already heard about that yesterday as well, that if we effectively use the forest, it actually gets more efficient. So if we take out the old trees, the young trees get more light so that they can continue to grow and bind CO2. Whereas if we don't use the forests, the old trees are going to fall, they're going to degenerate, and they're going to set free the CO2 again that they've bound while they were growing. So an effectively used, sustainable forest is actually better than an unused forest in terms of how much CO2 we can bind. In Switzerland, I think we're probably one of the only countries that doesn't have any monocultures. All of our forests are sustainably managed, and we only go there and take out the old trees. Then again, we have like apparently plenty of money to do so. It's not the cheapest way to work with the forest, but we also have a lot of forest that protects towns from earth slides or other natural risks. So we really need to take care of our forest. We can also build with earth or clay instead of letting it go to waste. We've already heard enough about this as well. Worldwide, we have a lot of waste that's actually the excavation. The materials, like in vernacular architecture, they looked at the materials and they used them in the way that it made sense. They didn't try to let bricks fly in the air. Just because we can do it today doesn't necessarily mean that it makes sense. So ideally, we go there and we ask, what's the material capable of? What does it make sense? How should we implement it? So timber and earth. Timber can be good for tension and compression, doesn't have a lot of mass though. Earth doesn't work with tension, but works pretty well with compression. Less well than concrete, but for many uses, it's plenty. The earth's fire resistance protects timber. We've already heard that this morning as well. We've also had to burn down some building elements, not yet whole buildings, but this one was burned down to check the system of Hortus. And it shows, you can obviously see the timber burns, the earth doesn't. Like there's no harm that's done to it when everything burns. And not only does the earth not burn, but it protects the timber that's right next to it from burning. So we don't need to over-dimension the timber if we protect it with earth. And if we think back to the most sustainable building and the empty slides, the less material that we use, the better. Because maybe we can build 2 buildings with the materials that we would have used for 1. The earth also adds mass to lightweight timber structures. We heard yesterday that it's actually good, the timber is light if you want to do like a top-up or like an elevation for an existing building, but it can also be not so good if you want to have mass for acoustics or you want to have mass for thermal inertia. In timber construction or in Central Europe by now, we have the issues that in summer it gets really warm, and we should try not to have our buildings heat up too much when it's 35 degrees outside. And if you have mass, you can prevent that a little bit, and you can also open windows at night, so you can have the night cooling, but you need mass. And we don't have that usually in timber construction. So what we do conventionally is we just add a lot of gypsum board which ecologically doesn't make a lot of sense. So we can just use waste, use less timber, and have the mass in the building. What's also good for the indoor climate is not only the thermal inertia, but also the porous surfaces that can store humidity and also give it off again. So if we have like an office and there's a lot of people there during the day, they breathe, they set free water while they're breathing, the humidity is increasing, it's getting somewhat uncomfortable, you feel like you should ventilate. The earth and also untreated wood, they can actually store some of the humidity, and then once people leave the room again, the humidity can be set free again, and you can kind of like equilibrate these high points of humidity during the days. Timber construction has been worked on for the last 30 or 50 years. Everything has been industrialized, many machines have been invented. We've seen quite a few ideas and proof of concepts today. We have many people here that are responsible for also these developments. And so timber construction has gotten quite efficient with the prefabrication possibilities and all the optimization in assembly and so on. We don't build timber buildings, except for maybe the Notre Dame, as we did like hundreds of years ago. Usually we prefabricate as much as we can. From that, I believe we can learn and we can apply it to certain areas of the earth construction so that we can also get more efficient in rammed earth construction. We have this advanced prefabrication, we have machines that assist the humans, we have quick and precise assembly on site so that the on-site time and the emissions that are created on site are as small as possible. We have proved connectors, which are also set out in the room behind there. Due to the prefabrication and the planning ahead, we also have a good reliability in cost and timing. We can really estimate how long is the building going to take, and we're actually going to be finished on time. Also, because of the prefabrication, we're not so dependent on the weather anymore. Of course, we still have certain times where we have to look out for the weather. Although when I hear that in Sweden you guys don't protect your structures from the weather anymore, I wonder what we do in Switzerland, because we're still protecting everything quite a lot. And especially when you build with earth, this is a really, really important part that you can't leave out, actually. So Hortus, the project that I'm here to present, the client was very important in this whole project because he wished to have a radically sustainable building. The architecture was done by Herzog de Meuron. The client works a lot with Herzog de Meuron together. The engineers were ZPF engineers. Both of them are based in Basel, like the engineers and the architects. We were assigned to do the timber construction and also the earth construction. And as a timber construction company, we don't tendentially use dirt, as my favorite carpenters in our company say. So we joined forces with Lehm and Erde to get that expertise. The office building Hortus is in Allschwil. It's close to Basel in Switzerland, and it's based in a big campus that's all been built by the same developer, and a lot of medtech companies are moving in there. There's laboratories and so on, and Hortus is part of this big development there. So it also, on some level, needs to be understood within the big development, because, for example, here and here, or somewhere there, yeah, here, there's like 2 parking garages. So Hortus had the benefit of not needing to provide any parking spots, which is good for its eco-balance. It's a 5-story office building. It doesn't have a cellar, which is very unusual for Switzerland. In Switzerland, right now, I think in St. Gallen, we're building like a building with, I think it's like a 10-story cellar or something, which is somewhat ridiculous. But Hortus didn't need to build a cellar because they had the parking houses next door. This, of course, was very good for the eco-balance of the building because the garage has a lot of concrete, or like a cellar has a lot of concrete and needs a lot of energy. The planning process for Hortus, I was personally not involved in that, but I've learned a lot from the architects, and I'm going to try my best to talk to you about it. The planning process was different. Usually, the standard way, I guess everybody who's an architect or an engineer will know this. You usually start with a program. You know what you have to build. You do an analysis of the site and you create your concept. And then you think about the structural system and the materials. And in the end, you come to the building elements and how the things are connected. For Hortus, it was different. The client set very high sustainability goals and also monitored them. I'll show you how. And out of these sustainability goals, they looked at the elements, and we heard yesterday, I think it was as well, that like most of the gray energy that you put into a building is within the slabs. So they focused on the slabs and created the slab system first. So they started with the building element, and from the building element, they scaled up, they did the full concept, and in the end, the project. So for everybody involved, it was a very different process than what they were used to. As I said, the client wanted to build a radical sustainable building. Everything else that they're building is like a concrete monster, but they've tried something new with Hortus, and I hope that it will persist and also continue in other projects. One aspect was that circularity needed to be part of the concept, so they wanted to, even though everybody hopes, of course, that it will last for 800 years or more, if it would be disassembled, that you could disassemble it and also use it somewhere else. So that was already part of the concept. The idea is to build circular from the beginning instead of recycling at the end what you can save. They also wanted to use the resources that they're actually having to use them efficiently. Not only the land, like the land they're doing mixed use, so there's some co-working there, the offices that are there, they're going to share the meeting rooms, there is the ground floor where they also have other meeting rooms together, so that the meeting rooms don't stay empty, but everybody can share them, and they're like ideally used. And also the flow of material, they wanted to use as much of the material as possible instead of letting it go to waste. They, of course, wanted to have ecologic energy and also certify the building. The goal was, or like the story of Hortus is that it should be energetic amortized within 1 generation. So more or less 30 years. Meaning that after like all the gray energy was calculated that would be emitted while building the building, and then with the production of the solar power from the roof and the facade, you would have more energy being produced during the year than you would be using, and by that you are paying back what you've used in gray energy, and you will be energetically amortized. That was the concept and the idea of Hortus. It's SNBS Platin certified. SNBS is like a Swiss standard for sustainable, I don't know, building and whatever. It has like 65 aspects of sustainability and what you need to look out for, and Platin is the highest possible certification. They didn't only set the goals, but they also measured them. So they had like their own tool where they kept looking at the eco-balance of the building, and they kept looking out for where are we standing in our goals that we've put. So here on this graph, we always also have the blue thing, the blue lines. They're the SCA, they're a Swiss standard for certain things, and the SCA 2040 is the new standards for sustainable building in Switzerland. So these are the goals from the SCA, from the new standards of sustainable building, and the green one is what Hortus is actually achieving. So they want to go a lot further than the new standards for sustainable building of Switzerland, just to prove what could be possible. And they looked at certain areas, such as like the percentage of materials from non-renewable resources, which obviously should be as small as possible. However, from renewable resources, the percentage should be as high as possible. The pure materials, they tried to use as many materials in their pure form as possible so that they would be easier to reuse. And they had the amortization time. In this graph, they stand at 31 years. I think by now they're like at 32. You can see on the left-hand side, like it started a little bit lower. It's kind of like the costs. Once you start to think about the building, you're like, oh, it's about this much. And then you realize, oh, I forgot this, I forgot that, I forgot that. And then it just keeps going up. The same goes with the eco-balance. As much like everything that you forget to calculate doesn't count on the eco-balance. And once you think about it, it will add. This increase here was because at some point in the project, they randomly decided to have an automatic ventilation system, which at the beginning of the project they didn't, and it cost them 2 years in amortization time. They decided to have a ventilation system anyway because they believed it wouldn't be good if people would be working there and you'd suddenly have a bee in your office or something, which, I don't know, maybe for medtech it's not good, but I wouldn't mind that much. So as I said, they first focused on the slabs because most of the gray energy is in there. This is a graph from the engineers. They looked at different slabs and calculated how much is their impact environmentally, and they looked at the slabs so that they would all have more or less like the same performance in terms of acoustics. And then one of the slabs won, and it was the timber earth slab elements that at some point we had the chance to realize. You can see a visualization here. So it's basically, this is basically the timber element. So it's a timber frame element that is then being filled with earth. The earth is being rammed, then it's going to be flipped over and going to be placed inside the building. Sounds like a very simple concept, wasn't as simple to realize, but we did get there. The building is getting opened. I think it's today. Out of this element, they had like a certain grid, so they knew the element would span such and such, and then out of this, Herzog de Meuron designed the building. And they looked that the grid would be very much repeated, so that it would have the same spans all the time, so that in theory, if like for some bad reason in 50 years they would decide to tear down the building, that the theory would be like you could take the elements apart and then maybe build a new building out of the repetitive elements. The ground floor has like a mixed use of, I think it's a gym, a restaurant, and meeting rooms, and a cafe, and the other 4 floors are just office floors that are rented. For the material efficiency, they really try to, in every spot, only build what's really relevant. So we can actually see on the left-hand side, it's an image of when we just put up the raw building, basically. So the elements, they've just been set together. And on the right-hand side, it's the finished building. You can basically nearly not see a difference. And that was the idea. The idea is to not have like any further layers or materials that are not really needed. So the structure was already the finished building. They also decided to have the whole technical aspects, like the light and the electricity, to have it all, like you can see it. So when there is a cable for a lamp, you can see the cable that goes to the lamp, with the idea that if in like 30 years or something you need to replace it, you can just go and do it, instead of like having it all kind of hidden in concrete or something and never be able to reach it again. They also decided for the top levels to only use double-glazed windows, which is unusual for Switzerland. We now use usually 3 like triple-glazed windows, but because the eco-balance of the triple-glazed windows, like the gray energy embedded, is pretty high, and because it's not as cold in Switzerland anymore, we have more problems with like overheating due to the sunlight. They decided to have double-glazed windows on the top levels, but have a bit more like thicker wall elements. The opaque elements, they're thicker and with good insulation. So by the insulation is the recycled old paper that somebody had already been talking about as well, Isoflok. So it's just recycled newspaper. And yeah, so it was a conscious choice not to have triple glazed windows because of the gray energy. In Switzerland, we've invested like 30 years in kind of like really well insulating our buildings and having a lot of insulation. And now we've realized, well, the gray energy is like a very important part as well. So interestingly, we're trying sometimes going back to what we had before. As I said, the facade and the roof, they're creating solar power. On the left-hand side is an image of the finished building. It's all around on all 4 facades, even though on some there is never any sunlight, but like the indirect sunlight also creates solar power. And by now the solar panels have gotten that efficient that it also still makes sense to have them there as well. So the solar power is being generated. We're generating, like they calculated that the building would be generating 800,000 kilowatt hour a year, and the building would only use 370. So it's nearly like less than half of what is being produced. And with that, they can make the amortization possible. Also, you can see maybe like the solar power panels, they're like a bit inclined. This is on one hand good because it can get more sun, but on the other hand, it also creates shade for the windows below, which is good for overheating in summer. Because if you have like kind of little roofs that cover your windows, you don't have so much light that enters and you don't have so much an issue of overheating. There's also like blinds to keep the sun out if necessary. So this was all that the team thought about before we actually were part of the building. But then obviously somebody needed to put the theory into practice. And this is where we, Blumer, Lehmann, and Lehm Erde, came into play. We had the challenge of creating 810 slab elements, 12,500 square meters of a system that nobody had ever built before. Also, the idea was to create the whole thing on site, because we were supposed to use the excavation that had been, that was there on site. We received the contract in January 2023, I think it was, and we had to start producing in May. So we didn't really have a lot of time. We also, on the side of that, needed to get wood, because the beams, these ones here, they're out of solid timber. So one beam comes from only one tree, it's not glued. It's also something we're not that used to anymore in industrial timber construction, because we like to have the glued things because they stay in shape and they're like very clear how to work with. The natural, like especially in these dimensions, they do sometimes change their shape. Apparently for Notre Dame, this was the idea. For us, it's very unusual and we had to learn how to work with that. So we had to go find the trees, because obviously also the trees needed to be sustainably harvested. So we went and talked to the forestry around us. The red dot is Blumer Lehmann, our timber construction company. You can see Zurich over there, and the furthest point is like 95 kilometers away from our factory. So we didn't really go that far to harvest all the wood. Ideally, we would have dried it in fresh air, but obviously timing was also very important, so we ended up having to dry it also in the ovens. The beams were not only pretty big, but they were also kind of long, so each of them has a length of 5 meters 40, which exceeds our standard. Our standard length that we have in our sawmill, Blumer Lehmann also has a sawmill, it's not only a timber construction company. So the standard length we have is 5 meters. So because of that, we couldn't just use what we had to go talk to the forestry and get the 40 centimeters extra. Then they were sawn into these big dimensions. You can see one of the beams here. And then we tried to keep them drying natural as long as we could. Good places were at the side of the road or railroads, because the air kept being moved. But we still had to put them in the ovens. Of course, the ovens are fired by like residuals from the timber sawing and so on. So it's not like very bad, but yeah, it still takes energy. Then we assembled the long beams together. We assembled them together where we could, because if you have two that are put together with a wooden dowel, they don't turn as much because they're kind of stabilizing each other, which is precisely what's happening when timber is glued together. It's stabilizing each other because it's not such a homogeneous material. And then we assembled the timber elements in frames. The secondary beams are the solid wood beams out of fir. And then we have the primary beams. They are beech wood. That's also being produced in Switzerland with Swiss wood. It's a new company, and they're not doing like the kind of LVL style like Baubuche, but they're doing Stabschichtholz, which is basically they're like doing cross sections like this out of beech, and then they're gluing it together. Like if you chop it, it looks like a chopping board with little squares. It uses only 10% of the glue that LVL uses. So that's why this material was chosen. It's also quite significantly more expensive, but hopefully they will find measures to make it cheaper at some point as well. So this was the timber part. That was also somewhat hard for us, even though we have built a lot with timber. But then the earth part, we were so lucky that Lehm Erde took the time and took us by the hand and worked with us together. We sat together, we had many discussions, we had to find new ideas. We came with our timber construction knowledge and our industrialized factory ideas. They came with the earth logistics, and somehow we had to meet and create this new production that nobody had ever used before. Luckily, the client had a lot of land, so we can see this is the construction site of Hortus, the blue square, and the green square was an empty plot that we could use for the filling of the rammed earth. We can also see that the plots that we used for filling the elements was actually bigger than the construction site itself, because the whole logistics and all the material and everything just needed a lot of space. We did some sketches, we had different ideas, how should we move the machines or should we move the elements, and then at some point just decided, all right, we just have to get going because the timing ran out. So we ended up creating a little tent city. It looked like a little bit at Oktoberfest, just with a little bit less beer. And we had a production tent, we had a mixing tent where we pre-mixed the rammed earth material, we had a mixing area where the big loads of material were mixed together, and we had 2 buffering tents where we stored the finished elements until they would be placed inside the building on site. In total, we used 3,000 tons of material for the rammed earth, and we calculated with 100 days of production, so that would have been 30 tons of earth that had to move from like a hill into the elements and be compacted within a day. The 30 tons were obviously nothing that a man would be wanting to do by hand. So this was what we focused on with our innovation that we had in the little time that we had to create this factory. And we built this machine, which is basically a steel frame. The whole logistics were done with a forklift on site, just because we weren't in a factory and we didn't have a crane, so we had a forklift. The forklift placed the element, the steel frame kind of came down onto the element and made it to stay in place. And then we had this little wagon thing that we invented specifically for the project, and that then filled the element with the rammed earth mixture. Because the whole logistics of the material needs to stay in the good shape. If you have it demixing with the different components, then you will have like gravel nests, kind of. And if there's just gravel and no clay, it may fall down on you, which wouldn't be good. Here is a photo of the mixing of the material. We had 3 different components. 2 of them came from the excavation material. 1 was just gravel that we bought from the area around to make the mixture complete. Basically, we took 2 shovels of one of the other, and 1 of the other, and then it was kind of pre-mixed. Then it went into the mixing tent, where it went to a conventional, like concrete mixer, a small one, so that the clay particles would really be mixed well with all the rest. And then it went over conveyor belts into the developed machine that we developed. And this machine then filled the elements, and then we started compacting. So when you think of rammed earth, you always think of, oh, it's a lot of work because you need to compact the earth. And it is a lot of work, but it's also the whole logistics of the material is like a very hard area to focus on. It was then filled with the machine, and then it was compacted. Some of it was compacted by hand. This one here is like a pneumatic rammer, and it shakes the material, but also the person. Luckily, we had people who were willing to do this, and then also we had, this was a second part of innovation that we did like 2 or 3 months into production. We couldn't do it before because we had to focus on other areas, but it's a rammer that's also used in like road building, and with this, we called it in German, it's a rollator. I don't know, maybe in Norwegian it's the same, like what the old people used to walk. So we created this rollator for the machine. So it would ram. It's like 400 kilos heavy, so it needed to be kind of guided by something. And then the conventional, I also don't know the name in English, it's also used in streets, like the vibrating plate. What you don't see on this photo is the noise. There was so much noise, like it was intense and you could hear it all around the area. It's the whole compacting of everything and all the machines go, and like it's really, really loud. So we were lucky that most of the places were offices, like nobody wanted to sleep in, and it's still a construction site anyway, so it was okay. We had some post-processing to do for the seams at the end of like where the timber would be meeting the earth. You can see here like one nearly finished element, and then we turned the elements immediately, even though the clay wasn't dry yet. The benefit from that is that like we could turn it, and in theory we could have turned the element and placed it inside the building the same day. So we didn't need space for having the rammed earth dry. Normally you need to let rammed earth dry so that you can put weight on it. But since the rammed earth in this system carries only itself, you can actually like load it immediately with its own weight. We then brought it into the storage. We had our little tractor here that needed to be acquired. to bring the elements from the factory to the construction site itself. To give you a little bit of a perspective, like we had actually special needs for the trolley here so that we could put 4 elements on top of each other. One element weighs about 3.5 tons due to the rammed earth. So we had special requirements. We found this special trolley so that we could create these 4 storage of 4 over each other. The empty elements, the timber elements that were stored here, they came from our factory. We had 7 elements on one trolley, and they came with like 2 carriages, basically. So we had 1 truck, 14 elements from our factory to the site, but then from after they'd been filled with rammed earth, we could only have 4 in one transport, because the rammed earth is a lot of mass, which is wanted, but also sometimes a challenge. The elements were then placed by our team onto the studs and into the system. And what's interesting here for me is that like our team on site, when we were building, there were a lot of people who came to do a visit of the building. And I was always guiding them and telling them about the production and everything, and our guys on site, they didn't understand why everybody came to watch. It was just a normal timber construction. And I think this is one of the really big benefits, that most of our company, except for me, like most of Blumer Lehmann, they didn't understand what was special about the building because it was just a timber construction. But then there was this little crazy tent city where it was all filled with rammed earth. But for everybody else, the processes stayed the same. The elements were a bit heavier, but other than that, it was fine. The elements were then screwed together. This was part of the circularity concept. The idea was that you would screw the elements together so that at some point you could disassemble them. But this will forever stay theory. Screws that will be taken out again of wood is like an imagination and does only exist on paper. So there definitely new ideas need to be found. I have seen some new ideas that have definitely got more potential with the X-Fix connectors that you have behind in the hole there. And I think it's definitely something to be looked into more than the screw. Yeah, the screw thing doesn't work. We were also discussing this morning the gypsum boards. What should we use instead of gypsum boards? We used clay boards. We didn't have to burn down a building for this. We had some professor from ETH who just signed that it would be okay, and everybody believed it. So we could build this. It was prefabricated already in the factory. You see one element here. It was for all the stairwells. So the stairwells, they're out of basically timber boards that are doweled together, and then they're cladded with the clay boards. The issue was that the professor from ETH signed that it would be okay for like everything, but then all the doors and everything that's certified, they're always only certified with gypsum boards. So we had like several discussions and needed to find special ideas like how to do it with the clay boards. But luckily in Switzerland, human proper thinking is valued a lot, so you can talk to people and you can find solutions. This is an image of the finished interior. You can see the rammed earth slabs together with the solid wood. You can see the posts, the walls. This is the clay boards that have then been covered in clay plaster, and the floor out of oak. Everybody that's been in there has so far really liked it. I personally got very excited the first time I saw it in natural light. It does look very cool, and it has a really good feeling to it as well. So I'm wondering what the people will say that will have the chance to work inside the building. The timeline. So yeah, as I said, we got the contract in the start of 23. The excavation already started in April 23, so we needed to talk to the excavation guys so that they would properly excavate the material because we had to use it. Then the production of the timber started in June. The rammed earth, we started to kind of create the production place in June as well, but then we only started with the rammed earth production in August, and it took us until March 24. I don't think anybody's done the maths, but it's been more than 100 days, so we somewhat overestimated the speed that we would be working in. In the end, we did reach the speed that we would have hoped to have all the way through, but to give you an idea, at the beginning of the production, we produced 35 elements a month. At the end, we produced 35 till 40 elements a week. So the guys have really, really improved, and it was also due to like the second rammer and the things that we've implemented, but also just because if nobody has ever done anything before, you can't expect them to be fast. The erection of the structure was parallel to the production of the rammed earth and the timber production, so we went from September till April, and it's opening this week. On the right-hand side, you can see kind of these colored squares. Big buildings in timber, we always have to build them in like little towers because we always need to protect them from the rain. Because if it rains onto the surfaces, especially onto beechwood as well, beechwood is really hard to sand and you will definitely see it. So we always need to protect it from rain. And we obviously can't protect like the whole surface because it just takes forever. So we always go up tower by tower, and then we had like temporary roofs that we lifted onto with the crane each night. This is what the building looks like right now. I'm guessing the inner courtyard, like it has this inner courtyard, which is actually the Hortus. So it's the biodiverse garden, and it will probably grow a lot more and become a lot greener over the years. And then also here, this is an image from the courtyard into the restaurant that's there, and this is an image of inside of the restaurant. You can see it has a lot of wood. Up above are the rammed earth slabs. I'm sure once it's actually open, there will be a lot more photos online, but as of now, this is kind of what I got. So yeah, as I said, we increased our speed a lot. We didn't only increase our speed, we also increased our quality. I was working on site for a week to also get some hands-on experience. As said, I'm an architect, so it's not like I actually know the trade, but I was allowed to join the guys and learn a lot. The week I was there was the week where the stage 1 connected to stage 6. So we had the very first elements that were side to side with the elements from the last stage that we were working on. And I guess everybody can see the crazy difference in quality. So not only were they faster, but they also did a lot better. In the end, the building has less than 50% gray energy of a conventional building that we're building right now. So definitely a goal that has been achieved. The energetic amortization will probably be reached within 31 years. So luckily, a generation is a kind of flexible term and will also include the 31 years, not only the 30. And the graph shows the SEA 2040, so that's again this new regulation for sustainable building in Switzerland. The SEA requires you to build a building with gray energy like this, but then it will just keep emitting energy because you're using energy. Hortus, however, has like half of the gray energy and then also goes down because it's creating more energy than it's using. We used 90% pure materials for good reuse and recycling. This was an involuntary field experiment that we did. We didn't do our waterproofing as well as we should have. Water entered the element and the rammed earth returned to nature. So this can easily be done. We have involuntarily tested it. It could also be fixed on site because it was just this little bit. But yeah, the rammed earth, you can just add water and reuse it. The timber, you can just take it apart if you get the screws out and reuse it. So there's many pure materials that can be reused if the building will ever have to be torn down. So we learned a lot in this building, a lot more than what I'm able to tell you today, but we want to continue the innovation. We believe the combination of timber and earth makes sense if we want to keep building sustainably. So we founded Lehmann, Blumer, Lehmann, GBT, and Lehm Erde. I'm responsible for Lehmann, so is Martin Makowitz. He's also working at Lehm Erde, so he's like the earthen side and I'm like the timber side, and we're kind of by now a bit both because we keep learning. And we offer specialist planning because we think in Hortus we had the issue that the project was kind of invented, and then suddenly they realized, oh, 5 meters 40 is not your standard length. Like, no, it's not. And then we had like a lot of issues with not standardized dimensions and challenges that we needed to face within this very short time frame of needing to build the building. So what we want with Limit is to offer a possibility for planning teams, maybe architects or engineers, that want to build in timber and earth, but have maybe never had the opportunity to build a Hortus such as we could, and to add our knowledge of material logistics, of concepts, of details, of production knowledge and assembly knowledge, and make the project from the start a good timber and earth project. So that's what we offer with Limit, basically. We check out projects or ideas. If it's already the first idea, maybe some client decides I want to have a building out of timber and earth, and the team needs assistance, and then we can check which would be the perfect combination. Like, it doesn't necessarily need to be the precise slab we do for Hortus. It can also be maybe a wall. It can be a combination. Like, there's so many options in these materials, and I believe that we have many, many more innovations to do together and to find new options in timber and earth. We look at the details. We've already got some experience. This is a plan of a building that we're building right now. It's a single-family home, and we're looking at different options for like rammed earth on the inside, but rammed earth on the outside, and how is the insulation going to go through, how are the connections going to be, and we have the opportunity to try out many things in this building. We work on concepts for material sourcing, material logistics, and fabrication, because obviously the joint forces of Blumer, Lehmann, and Lehm Erde have a lot of experience in that. And panelization and assembly concepts. We try to do as much in prefabrication as we can, because you're not dependent on the weather, and you have more quality if you have a protected environment to create your building. So sustainable construction doesn't only need Limit, it needs everyone. It needs creativity and flexibility. This is one of our office mates doing an office on site in the production hall. It needs courage and energy from everybody, from the people that realize it, from the architects, from the clients, from everyone. And most of all, it needs collaboration and communication. This is me trying to understand one of our workers inside the factory. So we're looking forward to collaborate, and hopefully many of you will at some point want to build in timber and earth, and hopefully we will meet again and build our future together in timber and earth.
Thank you so much, Bettina. Amazing project. Proper human thinking. Love it. You talked a little bit about it in the end, but what are your thoughts of the future of these earth elements? I mean, this was, as we saw, it's quite time-consuming and a lot of physical labor. What are your thoughts of the further prefabrication of this and expansion of this building system?
I would say we as a company and all our mother companies, we work in a way that we usually do innovation with the projects. We're like very bad at just doing random innovation, but if we have a problem to solve, we can manage quite well. So with every project, I believe we can optimize more. So another optimization that definitely will be needed to look at is that we don't need as much shaken humans to make sure that the earth is compacted. So just every single step can be looked at and everything can be optimized, but also I don't believe we would be building the same factory in exactly the same way again. We would go there and we would look at the specific requirements and optimize like the logistics and the ramming, and potentially also collaboration with gravel companies or something, so that they would also be responsible for providing the raw material and not that it wouldn't completely be our own risk and aspects like this. I think the key is definitely like collaboration with people that know certain things and then bring them together.
Sounds smart. I'm pretty sure there are someone here that have questions for Bettina.
Thank you. I have one comment and two questions, I think. The first one is, I'm really happy to hear that you in Switzerland actually protect your building sites from water. We don't do that in the same, to the same extent here, and I would like to see more of it. I work with water damage both in building sites and buildings in use. Which leads to my next question. You say that when you had water intrusion, the earth disintegrated. What are your thoughts on risk for water damage during the use phase? Have you thought about where you did the plumbing and so on?
Yeah, so in Hortus, it's or like in general in timber construction, we try to keep all the water system in like one tower. So that's been done really well in Hortus actually. It's all around the centers, around the stairwells, and it's only there is like toilets and water, and in all the rest of the offices there is no water. So all damage that can be done is like somebody spilling the glass, which shouldn't be an issue because you can clean it up. Obviously, if somebody went there with like a garden hose or something, it wouldn't be good for the system. In the ground floor, there is actually a gym, and they have installed showers now, but it's the ground floor, so it's below the ceiling, and the floor to the earth isn't out of rammed earth, it's out of timber elements. So I think it's pretty smart to just have like a vertical distribution of water rather than having a lot of horizontal distribution. And by doing that, I'm pretty sure that there shouldn't be any water damage in the use phase.
Probably not. The second question was related, but in terms of fire risk, I guess you do not have a sprinkling?
No, it didn't need sprinkling. Then again, like the fire regulations in Switzerland, by now, the idea is that you need to get the people out. But once a building has burned, experience has shown that we usually like tear the whole thing down and build it new anyway because everything is burnt. And to kind of try and save it, you don't really know what's the quality still of the members, so usually it's torn down and rebuilt. So even if it had a sprinkling system, of course, at some point, like the earth would be coming down, and I think that would probably be an issue at some point. But here in this building, we're not like in a high riser, so all the requirements that we had was that the slab needed to resist for 60 minutes, the smoke and the fire. And it did in the testing, so it was fine, and we didn't need to use sprinklers.
Thank you so much.
Anyone else? Okay. I know that Allschwil Viak, they have built a little prototype of rammed earth construction in the end of the exhibition, so it's also possible to go there and touch and feel the material. Thank you so much, Bettina. It's a pleasure having you here, and especially on the opening day of your building. So great, and thank you for a very, very nice presentation. Looking forward to seeing the next buildings of Lehm.
Thanks, me too.
Okay, one more question.
You showed 3 machines. Which one did you end up with? The rollator or?
We used all of them.
All of them?
Yes, we used, you mean like for compacting the earth? Yeah, we used all of them. So the manual compacting machine was mainly used in the end bits because there it's kind of hard to reach with the other machines. And then the electric rammer, which is 400 kilos, was used on the whole surface. And then the vibrating plate did kind of like the smooth finishing in the end. So it was a whole process of like first this and then that and so we used all of the machines. Yeah. And many more.
Thank you.
Thank you.
Thank you.